Hello everyone, I am back for another video. This is video 1.d.3 and we're going to talk about what light tells us about atoms. Because since atoms make up all matter and light interacts with matter, they can tell us quite a bit. Okay, so here's the gist. An element emits or absorbs different wavelengths of light, and that can tell us a lot of different things about both its structure and relative quantities. There are three main types: infrared, visible, and general absorption, which is kind of its own little weird category that we're going to get to. Okay, so infrared. Infrared light is emitted when the bonds between atoms vibrate. Okay, we can make bonds vibrate. It's not very hard to do. Anytime you put something in the microwave, that microwave makes bonds vibrate. Okay, specifically oxygen-hydrogen bonds vibrating. Microwaves are great at heating up water, and they're designed to make those bonds vibrate. So the oxygen-hydrogen bond in those waters vibrate back and forth, and when they vibrate back and forth, it causes friction and it heats up the food. Alright, that's why if you've ever noticed, if you put really dry food in the microwave, it doesn't heat up as well as moisture food. And that's why also when you put like a piece of fried chicken in the microwave, it comes out soggy, because you're heating up the hydrogen and oxygen bonds and you're heating up those water molecules and you're making them boil. You're essentially steaming the food from the inside out, and steamed fried chicken never really caught on. Okay, so infrared, it tells us what types of bonds are present. A single bond will vibrate differently than a double bond. Double bonds are shorter and they'll vibrate much faster. And triple bonds even shorter still. Also, what types of bonds in relation to what elements are bonded together. An oxygen-hydrogen bond will vibrate at a different wavelength because the length of that bond is different than a carbon-carbon bond or a carbon-oxygen bond or a carbon-carbon double bond versus a single bond. All of these things vibrate at very specific wavelengths. So if I add energy to an unknown substance and I get this infrared light coming out, I can isolate the different wavelengths and I can look at a table and just see what wavelength those bonds will vibrate at, and I can figure out at least the bonds present. So I can do a couple of different things to figure out the elements, then I can figure out the bonds present, and then it's kind of like a puzzle. It's a matter of putting it together in the correct order. Okay, so that's infrared. Visible and UV. Okay, so visible and UV light are like light bulbs or anything that glows. It's emitted when electrons move down energy levels. So when I turn the lights on in this room, I flip a switch and electricity goes through the bulb. These are fluorescent bulbs. It goes through the bulb. That excites those electrons into a higher energy level. I'm adding energy. The atoms absorb it, and the electrons go up into a higher energy level. When they fall back down, they lose energy. That energy has to go somewhere. It doesn't just stop. It doesn't disappear. It's emitted as visible or UV light. Okay, so one electron going from energy level 2 to 1 will emit a different wavelength or different color of light than one going from 3 to 1, or 3 to 2, or two of them going from 6 to 4 and 3 to 1. Things like that. And by looking at the different wavelengths of the colored light, we can compare it to standards and we can identify what element is present. And ultimately what electrons are there and the configuration. Because the movement of an electron between energy levels is unique, and it produces a very unique color. And so it will produce, a very unique, almost fingerprint, rainbowy thing. And we'll do that in class. There's a fun, super fun little activity that we'll show you. And then last but not least, absorption. Absorption is in a category of its own because it's not talking about the atomic level. Infrared and visible are talking about the atomic level. Absorption is not. Absorption pretty much is just saying that if I have a solution, all things being equal, the one that's darker in color is more concentrated. So if I have a solution of 0.1 molar and 10 molar, of let's say copper sulfate, it's blue. It's pretty blue. We'll deal a lot with it in class. The darker one will be the 10 molar, and the lighter one will be the 0.1 molar. And then we can use a colorimeter or a sensor that senses color, and that will help us figure out exactly the concentration. And we'll do a lab with that, and you've actually already done the lab with that, and I'm sure you thought it was super fun. It has a weird name. A professor named Dr. Beers came up with it, so it's called Beers' Law. You guys always think that's hilarious. Alright, so that is pretty much how we use light spectroscopy. So these last couple of videos are how we identify the inner components of the atom. So we can use mass spec to determine what kind of neutrons are present in the nucleus. And we can use spectroscopy to determine what's going on with the electrons. So hopefully you're picking up on those overarching trends. Alright, I will see you in the next video, or probably more likely in class tomorrow. Thank you.